So far in chapter 5, we've talked about quadratics, right? What is special about quadratics and makes them quadratics? They make a parabola, but in their equation, what makes them quadratic?
The x squared part.
X squared part, yes. What were you going to say, Kobe? Nothing. Okay. The x squared part, and they make parabolas. Very good. And the second half of last week, we did factoring, where we broke it down from standard form into different little chunks, binomials. We're going to kind of use all that together today to solve these quadratic equations. Now, when I say solve, it means something very specific. And there's actually 4 different ways to say it, and you have to be able to recognize all 4. So if you are asked to find the zero of a function, that's the same thing as finding the solution of the equation, which is the same thing as finding the root of the equation, which all of them are the same as finding the x-intercept. Not y this time, x. Okay, all those terms mean the same thing. What this looks like on a graph, okay, if this is our parabola, these are what we're looking for, that point and that point. Those are the x-intercepts. We can also call those the root of the equation. We call those the solution, and we also call them the zeros, okay, because it's where y equals 0. All those are the same thing, so recognize all those terms. We have 3 different ways that we're going to use today to do this. The first one you should be very good at now. It is factoring. This is pretty easy, especially if it's already broken down. If it's already factored for you, then it's pretty easy. All you have to do is set each factor equal to 0 and then solve for x. So that's factoring. We'll do that here in a minute. The other way is by taking the square root. This one, it's sometimes quick and easy if it's set up to be where you can take the square root. And we'll look at that where you can see that you can easily take the square root. We'll do that on the back. The last way is graphing on a calculator. This is usually the easiest, especially if your answer is an integer, like if you can see obviously on the graph that it goes through the x-axis at 1 and 2 or something. If it's pretty obvious, then that's pretty easy. But your calculator can also get really specific if it's decimals or something, and you use the 0 function that's in the calculator. I will show that to you. We'll write down how to get there and everything. That's on the back of the notes. So let's start with factoring. It's our first way to solve these equations. We can do this because of this 0 product property. Okay, it says that if a times b equals 0, then we know that either a equals 0 or b equals 0 or they both equal 0. Okay, right? If I say blank times blank equals 0, so one of those blanks has to be a 0, right? So that's where this comes in. So, how we look at this is, for this example, if x plus 2 times x minus 5 equals 0, then that means x plus 2 has to equal 0, and x minus 5 has to equal 0. So we have set each factor equal to 0. And now you solve each of those for x. So in the first one, we're trying to get x by itself. So let's subtract 2 to the other side. So what does x equal there? negative 2. And the other one, we'll add 5 to the other side. What does x equal there? 5. So those are the two places that our graph will cross the x-axis. At x equals negative 2 and x equals 5. So we call those the roots. We call them the zeros. We call them the solution. We call them the x-intercept. All those names mean the same thing. Any questions? No? That one was pretty easy because it was already factored for you. The next one, it won't be too bad because I think we can factor it easily. Is there any common factor we can bring out to the front? No? So we set up our big X. What goes in the top of our big X?
A negative 18.
Negative 18 from A times C. What goes in the bottom? 7. All right, what two factors of negative 18 can add to get 7? 9 and negative 2. Yep, that looks like that works. Very good. Okay, then we set up our fractions. 9 and negative 2 are the numerators. What will the denominator be? 1 from the invisible 1 there in front of x squared. So what are our factors?
X plus 9, x plus 2.
Very good. And from the equation at the very beginning, those equal 0. Now is where we set each of them equal to 0. So x plus 9 equals 0. X minus 2 equals 0. What are my solutions? Very good. X equals negative 9 and x equals 2. Any questions there? No. The next one, is it ready to be factored? No, because we're not in standard form. We got to get to standard form. So what should I move? That 40 needs to move to the other side. So we get x squared minus 18x minus 40 equals 0.
What do you have to do? Why can't you just say c equals 0?
Because it's got to be in standard form in order to factor. So that in standard form, it either has to equal y or it has to equal 0. One of the two.
Oh, yeah.
Oh, yeah. All right, so let's factor this. I don't think there's a common factor to bring out to the front. So what goes in the top? What goes in the bottom? Okay, so what are our two special awesome numbers?
20, or negative 20 and negative 2. Positive 2.
Yeah, positive 2. Okay, so those multiply to get negative 40, and they add to get negative 18. Make sure when you're using a negative and a positive that you've got the negative on the correct number. Okay, that'll just depend on whether this is negative or not. Negative 20 over 1.
So x minus 20.
X plus 2. Now all equals 0. So what does x equal?
X equals 20 and negative 2.
Very good. X equals 20 and x equals negative 2. So that's where our graph crosses the x-axis at 20 and negative 2. No. Now I'm recording. That's good. Okay. One more. Let's see if we can figure this one out. So is there anything common to bring out to the front? Between 6x squared and 18x.
Well, I mean, yes, but, okay.
Let me rewrite this over here.
But what about
What's common?
the 6x?
A 6 and an x. Okay, so divide each by 6x. So if you divide each by 6x, we're left with 6x times, boo!
You get x plus 3x, 6x outside.
Okay, so x plus 3.
X. Yeah.
Yeah, because that canceled, that made 3. That canceled there, that canceled. Okay, so there we go. So in this, 6x is a factor and x plus 3 is a factor. So we'll set each of those equal to 0. So 6x equals 0 and x plus 3 equals 0. Let's see, let's divide by 6. So x equals 0. Subtract 3. X equals -3. So those are the two factors for that equation.
Do you have to go there, Miss Carter?
All right, so the next part is that we're going to solve by square roots. We use this when everything is a perfect square. This doesn't always happen. It only happens sometimes, but when it does, it's awesome because we can solve it pretty quickly. The only trick is that you have to remember this. If you take an even root, so that's like square root, fourth root, sixth root, any of those, of both sides of the equation, then you must insert a plus minus, which is weird, but it's very necessary. If you don't do that, then you only have gotten half of your answer. Okay, so that's not good. We need a whole answer. I'll show you why we need this. Okay, so let's look at the first one. If we can get this 49 to the other side, can we take the square root of it? Yes, so let's add 49 to the other side. So our problem now is x squared equals 49. Well, are both sides perfect squares? Yes, we can take the square root of both sides, so we're going to do that. So what's the square root of x squared? Just x. A square root and a squared cancel each other out. So all you have left is whatever was being squared. And what's the square root of 49? 7. But we took the square root of both sides, so you have to put in a plus minus. Now, why do we have to do that? Well, what is positive 7 squared? 49. What is negative 7 squared? Positive 49 again. So we don't know which of them x truly is because there's two options. So that is your answer. So you actually have two answers there. The graph will cross at 7 and -7. Any questions? All right, let's try the next one. Can we take the square root of both sides and get pretty answers right now? Can you take the square root of 2? No, so let's try moving it to the other side. What do we have when we've done that? X squared equals 4. Can we take square root of both sides? Yes, so what is our answer? X equals plus or minus 2, positive or negative 2. Doing good. The next one, can we take the square root of 36? Yes. Is this a perfect square? Well, is it something being squared? Yes, so it is a perfect square. It may not look very pretty, but it is perfect. So we can take square root of that side, square root of this side. So what's left if we take square root of x plus 5 squared? x plus 5. Because remember, the square root cancels with the squared. So all you have left is x plus 5. And then what do you have on the other side? Plus or minus 6. Very good. Now we're solving for x, so move the 5 over by subtracting it. X equals negative 5 plus or minus 6. Are those like terms? Can we usually add a negative 5 and a 6? Yes, so we have to go ahead and add them, but we've got to do it twice. Once for the positive, once for the negative. So what is negative 5 plus 6? Positive 1. What's negative 5 minus 6? Negative 11. So those are your two answers. So these are awesome when they're set up in perfect squares. If they're not, then you may have to move stuff around, or sometimes it's not even possible because they're just not perfect squares. But probably the ones that they'll give you in the book today, it will be. You got questions? No?
So that's just a different way of doing it?
Yes. Yes. Just
Will
a
it
different
tell
way.
us, like, which way to use it
Yeah,
in the book?
today in your book it will. Yeah.
Okay.
And on your test it will. In life, in real life, probably won't. Okay, so this last part we're actually going to use the calculator for. I'm going to write out the steps first and you can copy them down and then we'll actually do it.
Aren't these already on the board?
Yes, that was from last period. So the first step you're going to do is get your equation in y equals in the calculator. And then you'll graph it so you can see it. And then you'll hit second trace, which is the same thing as calc. And option number 2 says 0. That's the one we want. I wish that it could be number 0, but it's not. Okay.
Okay.
Oh, I need a dot there. Next, it's going to ask you for a left bound. You'll find that. I'll show you how. And then you press enter. Then it asks you for a right bound. I'll show you how to do that. And then you press enter again. It'll say guess. You don't have to do anything on that one. You just press enter. And then it'll give you an answer and you have to repeat because we actually have to do it more than once. I'll show you all of this. All right, so for the first one, well, I guess you need a calculator, so everybody get a calculator. So go put x squared plus 7x plus 10 and y equals.
And y equals?
Uh-huh. And then you press graph, and you should see something like what's on your paper.
Are they always going to equal 0 for the graph?
They always have to equal 0 for the graph. If they don't, that's a great question. If they don't equal 0, you have to mess with it until it does.
Well, how do we do that with no examples?
Huh?
No examples.
Okay, I'll make one.
Okay.
Okay.
Yes. Really quick.
All right, you have that one in the calculator? Everybody was able to get it graphed? So the points we're looking for are the x-intercepts, which are right here and right here, correct? So this one, you can kind of already see what the answers are, but for the more complicated ones, you need to follow these steps. So you're going to press second trace, and select option number 2 that says 0. And then it says left bound question mark, right? At the bottom of the screen it says that. So what that means is that it wants you to tell it where to look. Okay, so what is the left boundary of where it should look? I'm going to make it find this one first. So to the left of that is like here, and to the right is like here. So go find a spot that's on the parabola to the left. So that'd be like right there, and select that as your left bound. Okay, so it will look to the left of that point, and then go move to the right, select something down there, and that'll be your right bound, and it'll look between those two. When it asks guess, you just press enter, and it should give you an x equals a number answer. Now what's tricky about this is a lot of people want to move all the way to the right of the other point, and you can't do that. You've got to make it hone in on one spot, or else you're going to miss part of your answer. Because the calculator, though it is very smart, it can only do one thing at a time. Okay, so just make it kind of block in these points, and what does it tell you that spot is? X equals -5. So there's half your answer. Now you do the same thing for the other half, but now your left bound will be kind of below. So this will be left, and your right will be somewhere up here. This is really odd because we kind of see it as above and below, but the calculator is thinking about it as left and right. So it's kind of a hard connection to make, but once you've made it, you'll be good to go. So do that and tell me what x equals. -2 and -5. So those would be your two answers.
Can you find the second one? Just do the same thing over again?
Yes, same thing over again. That's the repeat part of the instruction. Any questions? If you are having trouble with the calculator, if it's doing something weird, please tell me so I can come help you. For the next example, I've actually kind of altered it so that you can have practice for something that will be on your homework. Thank you for the suggestion, Kayla. All right, before you can graph it, you have to get everything on one side of the equation. Okay, because we're replacing the 0 with y equals. So we need to make this thing equal 0. So let's move the -3x and the -2 to the other side. How will we do that? Add them, because they're both negative. So we've got now that x squared plus 3x plus 2 equals 0. Does that make sense? That we have to have everything on one side before we can put it in the calculator. You kind of have to do that with everything but the square root part. Factoring, it's all got to be on one side, and graphing, it's all got to be on one side.
So that's all we do, we just
Yep, and now you put it,
opposite to where everything's on one side. So like everything on one side would just go opposite.
yes, yes, yeah. Okay, so now go through all of your steps and tell me what you get. What'd you get?
I got for the first one, I got -2 and then the second. Yeah, that's what I got.
What'd you get for the second one?
-1.
-1. Those are correct. Do y'all need any help with this? Do you feel like we need to do the last example, or are you good? You're good? Nobody's responding? Okay, so
How do you get the second point?
so you do the same steps, you just, when it says left bound and right bound, you make it around that second point. I can come help you with it. If I suggest, since you've got the calculator and you're kind of on a roll, go ahead and do those problems first, which are the 23 through 31 odd. I suggest you go ahead and do those first while you have the calculator. All right?